Hello. For this sprint, I worked on three user stories. The first one is a gamification system. So, to support gamification, we designed a relational data model that includes tables for user points, achievements, and level progression. Each user's financial actions are tracked and logged with point values assigned per action. Example, budget creation, expense tracking, etc. This schema enables scalable tracking of user behavior while maintaining data integrity. The level system is structured using thresholds where each level has a title and a required point range, allowing users to progress and unlock new achievement badges. For this, we developed a dedicated service layer to encapsulate the point calculation logic and level assignment rules. We created helper functions such as calculate user points, get level from points, and get progress to next level, which provide reusable logic across multiple endpoints. The key API endpoints include gamification profile for retrieving a user's current gamification status and automatic point assignment hooks integrated into financial activities, example budget creation. This setup ensures gamification data is updated in real time and accessible to the front end. We wrote robust unit tests using Ghost testing framework to validate gamification logic across edge cases, including boundary level transitions and achievement unlocking. Test cover, uh, with test coverage, we ensured reliable point assignment and accurate API responses under various user actions. Additionally, we created internal documentation for the level calculation formulas, point rules per action, and integration guidelines for front-end developers consuming the gamification APIs. This ensures maintainability and smooth cross-team collaboration. And the next user story is the financial notification system. The notification system is designed around a central notifications table linked to each user. The schema tracks message content, notification types, example budget alert, milestone, timestamps, and read or unread status. We also introduced a preferences model that stores each user's alert configuration, allowing them to toggle specific types of notifications. This modular approach ensures the notification systems can scale with new types of financial alerts without altering core logic. For this alert generation logic, we used monitor user activities such as budget overspending or missing transaction logs and automatically triggering notifications. We developed endpoints like API notifications for fetching user alerts and API notification preferences to update settings and API notifications ID read for making alerts read or unread. Each endpoint includes proper authentication checks and optimized queries to handle large notification volumes efficiently. We wrote comprehensive unit tests to validate notification generation triggers, including edge scenarios like multiple budget alerts or toggled preferences. The tests also ensure API responses are consistently structured and informative. Together with inlay API documentation, this ensures the notification feature is production ready and front end friendly. And the third user story is the backend security and production readiness. Uh, we standardized the error handling across all API endpoints by introducing a centralized error response structure. This includes HTTP status codes, error identifiers, and detailed messages for front-end parsing. Additionally, we implemented structured logging using a middleware that captures errors, requests metadata, and stack traces. This simplifies debugging in both staging and production environments. Uh, a comprehensive security review led to several enhancements. JWT based authentication tokens now use short-lived access and refresh tokens to reduce attack exposure. Rate limiting was applied using middleware to prevent brute force attacks, and input validation was added across all user-facing APIs to protect against injection attacks. These updates align with backend with modern security best practices and OWASP guidelines. To ensure production readiness, we profiled key API endpoints and optimized their underlying queries, leading to almost 25% reduction in response time. These observability tools give real-time insight into system health, and support proactive maintenance. Um, Now I would like to show the curl commands for the APIs that are developed. Just a second. Started the server. Server is listening, and these are all the test cases, and these are all the curl commands, and these are all working. Yeah, and Gopinath, can you take over?
Yeah. So in this demo, we'll walk through the technical implementation of three key features for our financial application. So the backend test automation and spending pattern analytics and expense forecasting. So first, we implemented a test automation script that runs all the backend test suites, ensuring that each change is thoroughly tested before deployment. So we have integrated this testing process into a CI pipeline. So every time code is pushed, the tests are automatically executed, and the test environment is properly configured to match production settings. And also we have achieved over 80% test coverage across the application, so with the detailed test reports and dashboards that highlights any failing tests. And the next we have developed the analytics system to help users better understanding their spending patterns. So this include creating data structures to store transaction data, and developing logic for calculating expense categories and trends, and building API endpoints for retrieving spending summaries and identifying trends. So we also wrote a comprehensive unit test cases for all the analytic functions, ensuring they work accurately with real and mock data. So these tests cover a wide range of edge cases to guarantee the system generate reliable insights, including category breakdowns and trend analysis for using spending over time, for user spending over time. So finally, we have also implemented an expense forecasting system that predicts the spending based on historic data. So the forecasting algorithm identifies recurring expenses and projects them for the next 1 to 12 months. So we created an API that allows users to request forecasts, and we added validation to ensure that only valid time periods are accepted. So the system handles edge cases and errors gracefully, providing accurate predictions for users. And the comprehensive unit test cases were written to ensure the forecasting logic works as expected, covering all the possible scenarios and edge cases. So this ensures that users receive reliable financial predictions to help them manage their budgets effectively. So now we'll run the test files. Yeah. So these are the test cases for the new features that we have implemented for this sprint. So this includes analytics and the notification systems and all the features that we have implemented in this sprint. So, yeah. So as you can see, all the test cases have been passing, and we have created a shell script for running all the tests in the project. So we are running it. So, yeah. So all the tests are passed in the project. Yeah. That's it. Shipra.